Okay, introduction to definite integrals. Okay, the purpose of an integral is to find the accumulated area between the curve and the x-axis. Okay, so there's my shade and region there. I'm going to set up an integral, and it goes from -3 to 0 of negative x squared minus 3x dx. Okay? Now, the Fundamental Theorem of Calculus says the integral from a to b of f of x dx is the antiderivative evaluated at b minus the antiderivative evaluated at a. Okay? So, this capital F means antiderivative of function f. Okay? So, I'm going to take the antiderivative and get negative x cubed over 3 minus 3x squared over 2. Put that in brackets. And I'm going to evaluate that from -3 to 0. And then what I'm going to do is I'm going to plug in 0. So I get 0 cubed over 3 is 0. Minus 0 squared times -3x is 0. Minus, I'm going to plug in -3. So I get -3 cubed is -27, but that's negative. It's a positive 27 over 3 is 9. And -3 squared is 9. Times -3 is -27. So I get -27 over 2. So that's really negative, let's say 18 halves minus 27 halves. So that's really negative 9 halves, or 9 over 2. So that's the area of this region. The area is 9 over 2, or not about, but exactly 4.5. Okay, let's look at another one. Okay, let's see. They gave me this curve, and I'm going to label it y equals 2x squared minus 3x plus 2. And they want it between 0 and 2. So I want this shaded region all the way up here. Okay, I want that area of that shaded region. So I find that, yeah, and the x-axis was included too, right? So I want, let's see, 2x squared minus 3x plus 2 dx. Then I want that from 0 to 2. So I'm going to take the antiderivative and I get 2x cubed over 3 minus 3x squared over 2 plus 2x. Actually, I'm going to do square brackets here. From 0 to 2. So I plug in 2 and I get 2/3 of 8, which is 16/3. 2 squared is 4, times 3 is 12, divided over 2 is 6, and minus 6 plus 4 minus, now I plug in 0, I get 0 minus 0 plus 0, so that's all 0. So I get 16/3 minus 2. So 16/3 minus 6/3 would be 10/3, or about 3.3 repeating. Okay, so that's that area. Okay, so I'm going to look at number 3. Okay, find the area bounded by the graphs of, okay, so this one I'm going to actually have to graph it. I can use my graphing utility. Let's see. Y equals 1 minus the square root of, okay, so that's really y equals negative square root of x plus 1, so it goes up 1. And then it's a negative square root of x, so it's down like this. And then let's see, I want x equals 1. Let's see, so there's x equals 1, x equals 4, y equals 0. That's really the x-axis. And see, when I plug in 1, I get 0, so that's okay. So I just want that shaded region right there. Okay, now that should be a negative area, so what I'm going to do is I'm going to do this integral from 1 to 4 of 1 minus x to the 1/2 dx. Alright, so I'm going to take the antiderivative and I get x minus x to the 3/2 divided by 3/2 is 2/3. And then I'm going to evaluate that from 1 to 4. So I'm going to plug in 4 first, so I get 4 minus 2/3 of 4 square root is 2, 2/3 is 8. So now I'm going to plug in 1, I get 1 minus 2/3. So let's see, I get 4 minus 16/3 there, minus 1/3. So 4 is really 12/3 minus 16/3 minus 1/3. So I get 12, let's say I get negative 17/3 and 12/3 is negative 5/3. And that makes sense because the area of that shaded region is negative. Okay, so that kind of makes sense because below the x-axis area would be negative. And let's see, got one more example here. It's going to make it a little bit longer of a video, but that's okay. Alright, let's see, 2 minus x squared. So that's a parabola that goes down like this, and y equals 0. Okay, so now I need to know where those intersect, because I want that area, but I need to know where the points are. So I'm going to say 2 minus x squared equals 0. I'm going to set these equations equal to each other. And then I'm going to go, okay, 2 equals x squared. So x equals plus or minus root 2, which fits our graph, square root of 2 comma 0 and negative root 2 comma 0. So now I'm going to sub my integral, which will give me the area of that shaded region, negative root 2 to root 2 of 2 minus x squared dx. Okay, so I'm going to take the antiderivative. I get 2x minus x cubed over 3. And I'm going to evaluate that from negative root 2 to root 2. Should make that a square bracket. Okay, now I'm going to plug in root 2, so I get 2 root 2 minus square root of 2 cubed would be 2 root 2 over 3 minus, I'm going to plug in negative root 2, so I get minus root 2. And then let's see, I'm going to plug in that, I get minus, but that'll make it a plus, 2 root 2 over 3. So you get 2 root 2 minus 2 root 2 over 3 plus 2 root 2 minus 2 root 2 over 3. So what I get is I get 4 root 2 minus 4 root 2 over 3. And if I wanted one fraction, I could multiply, let's see, I can go this multiplied by 3 over 3 and get 12 root 2 over 3 minus 4 root 2 over 3, and that makes that 8 root 2 over 3. That's how you find the area of that shaded region. So the area would be 8 root 2 over 3, and that's of interest to us because in calculus, physics, a lot of science, finding the area will help you find things like work and distance or displacement and things like that. Alright, good luck.